For section 5.3, our goal is to be able to create a recursive and explicit equation for linear and exponential functions. This is a review from Math 1. 5.1, we went over the explicit for a linear function. 5.2, we went over the explicit for an exponential. So today, hopefully the only thing that we're going over will be recursive, which will look a little weird at first, but the more you practice it, the better it'll be. So, example 1, predict the next two terms in the sequence. State whether the sequence is arithmetic, geometric, or neither. Write an explicit and recursive equation for the sequences that are arithmetic or geometric. Okay, so that's a lot. So, two terms. Goal is to find the next two terms. I have 4, and it goes to negative 20, then 100, then negative 500. So that looks like 4 to 20 would be 4 times 5 times 5 is 5. Okay, so it's timesing by 5. But to get it to flip from sign to sign, I have to times it by a negative 5. Yep, there's my pattern. So I'm timesing by negative 5 each step, which means my next term, 2,500 times by negative 5, negative 12,500. Okay, there are my next two terms. Then it asks, is it arithmetic or geometric or neither? Well, whenever I multiply or divide, it is geometric. Okay, now I need to write a recursive and explicit. Recursive would be f of x equals f of x minus 1. This will be repeated over and over and over again. Recursive, f of x equals f of x minus 1. Every time. Repeat, repeat, repeat. And at the end, you put the pattern. It is multiplying by a negative 5. And sometimes I put parentheses because it'll look like a minus 5. Personal preference, but it's timesing by negative 5. The explicit would be f of x equals, I'm going to use the first number in my line, 4, times it by a negative 5, and then it'll be power of x. Because I picked the first term, I have to write minus 1 on it. So let's say you picked the third term, right? 1, 2, 3. You pick the third term. You would write f of x equals 100, then your pattern, power of x, you'd have to put minus 3 because you used the third term. Okay, so you can pick any number in your list, you just have to adjust your power based off the number you pick, okay? Next question, we're looking for a pattern, and we want the next two terms. 60 to 48. Let's see, 60 minus 48, 12 apart. 60 minus 12, minus 12, minus 12. Yep. So each time it's subtracting 12. So then minus 12 again, minus 12 again. There are the next two terms in our sequence. Whenever we are adding or subtracting, it is called arithmetic. So when I write my recursive, remember how I told you you're going to get tired of this? F of x equals f of x minus 1. Recursive every time. And the pattern goes at the end. Subtract 12. That's the recursive. Explicit. I'm going to use point slope form. So I know my slope is subtracting 12 each time. Then I can pick any term in my list. I'm going to pick the third term. I'll pick 36. This is my third term. So I'd write x minus 3. And at the end, it's a positive 36. That's point slope form. So I would write, let's say I picked the 24. I would have done negative 12 parenthesis x minus 4 because it's the fourth term. And then this would be a plus 24 at the end. Okay, if you do not like point slope form, you hate this form. You may also write it with the y-intercept. So it'd be equal to negative 12x. And then if you want the y-intercept, you just go back one step. So 60. If I go backwards one step, that would be adding 12, which is a positive 72. So you can choose to use point slope or slope intercept. Both are correct and great. Question C, we are looking for a pattern. Okay, pattern. 40 to 10, 5 over 2, 5 over 8. Okay, some of you might hate fractions. I love these ones. 5 over 2, 5 over 8. See how the pattern's 5 over, 5 over? 5 will definitely be on top. 5, 5. And then it goes from 2 to 8. Well, 2 to 8. Then the next one, let's see. 2 times 4 is 8. I'm just looking at the bottom of the fraction, okay? 2 times 4 is 8. Times 4 is the bottom. Times 4 is the bottom. Now, the bottom is multiplying by 4, okay? That means this is not timesing by 4. 40 times 4 would be 160. It is timesing the denominator by 4 each step. It's taking 1/4. 1/4, 1/4, 1/4, 1/4, 1/4. It is dividing by 4. That is called geometric. So when I build recursive, f of x equals f of x minus 1, and it is timesing by 1/4. Explicit, f of x equals, I'm just going to use the 40 times by 1/4, that's my pattern, power of x minus 1, because I use the first number in my list. Example 2, find the recursive and explicit equations from the sequence in a table. Okay, so instead of a list, we have a table. Okay, so pattern 19 to 16 to 13 to 10. That is subtracting 3 each step, which would be called arithmetic. F of x equals f of x minus 1 minus a 3. Then the explicit, f of x equals my slope. It's subtracting 3 every step. And then I can pick any of these points. So I'm going to pick the second term. x minus 2, second term, would be a plus 16. And that's my point slope form. Question B. 4 to 2, 2 to 1, 1 to 1/2. That's cutting it in half each step. So that's geometric. F of x equals f of x minus 1 times by 1/2. Explicit would be f of x equals, let's see, what number do we want to start with? 4, 2. We'll start with 1. Start with 1. My pattern is to cut it in half. And then my power would be x minus 6 because I started on the 6th term. If you started with 2, you did 2 times 1/2, you'd be x minus 5. Example C. We are given a table. The table is a little bit different orientation-wise, but same idea. -4 to -11, -18, -25. That is for 11, 10, 9, 8, 7. Subtract 7. Okay. That would be arithmetic. That would be f of x equals f of x minus 1. And then minus 7 is floating at the end. Explicit, f of x equals my slope. And then I can pick any point from my list. So 3, -11. X minus 3. And then minus 11 will be at the end. Point slope form. I love point slope form. It makes it a lot quicker. Okay. 2/5, 2, 2 to 10, 10, that's timesing by 5. Timesing by 5, geometric. So then my recursive would be f of x equals f of x minus 1 times by 5. It's like a little dot. And then explicit, f of x equals, where's my starting? Okay, which one do I want to start with? I'm going to start with 10. 10 times 5. 10 times 5. If I start with 10, that was the first term. So x would need to have a minus 1 on it. It looks a little weird. Let me fix it. It's minus 1. There we go. That's a little bit cleaner. Okay, next one, we're looking at 81, 27, 9, 3. That's 1/3. It's dividing by 3 each step. Geometric. Recursive would be f of x equals f of x minus 1 times by 1/3. Explicit would be f of x equals, I'm going to pick a number to start with. I'm going to start with 81. Times it by my pattern of 1/3. And the power would be x. Ooh, this one's different. This is a good one. Minus 4. So when I reset and align it in my equation, it should be a plus 4, x plus 4. Okay, and if you have questions with these, please ask. Our last example, example 3, create a recursive and explicit equation to represent the image below. We have This is 3 blocks. 5 blocks. 7 blocks. 9 blocks. Okay, cool. That pattern is adding 2 each time. Based off of that, it is going to be arithmetic. It's going to make a line. It'll be linear. So let's make our equations. Recursive. F of x equals f of x minus 1, and my pattern was adding 2. Explicit. F of x equals, which one do I want to start with? I want to start with 3, actually. No, this one's linear. This is a linear one. Okay, so my slope is adding 2. And then my first term is a plus 3. Okay, if you have questions, please let me know.